In Chapter 10, we're moving into something called hypothesis testing. Now, this is a really important idea. This and confidence intervals are basically the foundation for statistics. So if you were going on to another statistics course, you'd be doing a lot of confidence intervals and hypothesis tests. They are the mathematics that creates the foundation for all experimental science. So every prescription drug you've ever taken, somebody at some point did a trial with some samples and created some confidence intervals and hypothesis tests about that data. So we need to figure out how hypothesis tests work. In 10.1, we're going to talk about some facets of hypothesis testing. And then in 10.2, we're going to run our first tests. And then 10.3, we'll keep running tests. 10.4, we'll run some more tests, etc. All right, so let's talk about the language of hypothesis testing, section 10.1. So we're not actually going to run the full test. We're going to learn some pieces about that. Now, the first thing we want to kind of do is look at this exploratory example, because this is going to set up the foundation for all hypothesis testing for you for the rest of the course. All right, so in class, I have students roll a 6-sided die 12 times. So they take a 6-sided die, your average Monopoly die or whatever, and they roll it. And then they count the number of 5s that they get. So pretend you roll it and you get 2 5s or whatever. All right, so then I have my class data here. So I had 2 students that had no 5s. I have 4 students that had 1 5. I have 10 students that had 2 5s and so on. Right, 7 students had 3, 4 students had 4. This is actually the compilation of 2 classes worth of students, but bear with me here. 1 student with 5, 1 student with 6. Scrolling down. Nobody had 7, nobody had 8, nobody rolled 9 5s, 10 5s. And then 1 student right down here rolled 12 5s. Think about that. They took the die, they rolled it 12 times, and all 12 times it came out to be a 5. All right, so what are some possible conclusions we could draw from this? Let's take that student and call them Steve, say. All right, so Steve had 12 out of 12 5s. What could be happening? Well, it could just be random chance. I mean, it's possible. It's not very likely, but it's possible. As a matter of fact, let's figure out the probability of that real quick. So we learned this in chapter 6. N is 12. N is 12. You assume that the probability of success is 1/6, right? This is binomial, by the way, in case you missed it, right? So that means that the probability of 12 5s is equal to binom PDF 12, 1/6, 12. Let's find what that is, shall we? We have calculators. We can do this. Hold on. All right, let me grab the calculator. Clear this out. Go to distribution. Go to binomial, which is letter A, binomial PDF, because we want to know the probability of Steve getting exactly 12. There are 12 ties, 12 rolls of the die. 1/6 is the probability of success. And your X value was 12 because Steve got 12. And you see that? That's 4.59 E negative 10. So what that means is that the decimal is 10 spots over to the left. So 4.59 E negative 10. So this means the probability of 12 out of 12 5s is approximately 0.123456789 I'm just going to throw commas in there. I know it's not good standard form, but bear with me here because I want people to see how incredibly low this is. So it could be random chance, but it's highly unlikely. We just proved that. Okay. Now, it could be he's lying, right? He didn't roll the die. He just pretended to roll the die. He might be crafty. You never know. Matter of fact, you don't know because you didn't actually see this person roll the die. Or something else could be up, right? The die could be loaded. It could be rigged. Now, what kind of evidence do we have against or to support these conclusions? Well, we don't really have a lot of evidence for the random chance thing. Or let me put it another way. The random chance is so low that you don't think that's going on. And we, of course, are just assuming that Steve's a nice person and not lying to us, which means that we're leading ourselves towards this one. We think that something is going on. So how do we have evidence that something's going on? So we think, I don't know why my ink is that color. One second. There we go. So we think that the most likely explanation is that the die for Steve was rigged / loaded, right? Now, why do we think that? Our evidence can come in two different forms. The first type of evidence we can say is the probability of 12 fives is extremely low. Remember, we found it up here to be that small number. Very, very, very tiny. And if that's the case, oops, I should put that in there. There we go. There, I changed the word extremely to very because then I could fit it all in. All right, so very, very low. So if that's the case and it's an extremely low probability, that means that we think that it's more likely that the die was loaded, right? So it's very unlikely that Steve got his results by random chance. But I will put the word in extremely. Extremely unlikely that Steve got his results by random chance. Right, so that's that bit of ideas, right? That the chance of him getting what he got is so low. Okay, this is called the p-value method. P stands for probability, right? Right. So you say the chances, the probability, p-value, the probability is so low that you think that something's going on. So we think the die is loaded instead. Okay. P probability, p-value. All right, so that's evidence way number one. Then there's evidence way number two. So let me type that up one second. All right, so the classical method, let me highlight this one for you. The classical method, you have to think about the mean and the standard deviation and the z-score. So you say, look, the mean number of fives that I'm expecting is, now remember, since this is binomial, right, you have your independent trials, you've got your chance of success is 1/6, et cetera, and either 5 is success, everything else is failure, all that good stuff. Then n times p times 1 minus p, or excuse me, n times p is 12 times a 6, which is 2. So that's your mean. And then your standard deviation would be sigma, which is the square root of n times p times 1 minus p, which is what I was talking about earlier. 12 times a 6 times 1 minus 1/6, and I take the square root of the whole thing. So square root 12 parentheses 1/6, close parentheses, open up the next parentheses, 1.29. See? Okay, so 1.291 if you like. All right, so if that's the case, then I want Steve's z-score. So I'm going to take his z-score, which is the value he got, which was 12, take away 2, which is the mean that we're expecting, divided by 1.291. So let me grab a calculator. 12 take away 2, well, here, parentheses. 12 take away 2, close parentheses, divided by 1.291. Or if you like, you could divide it by that last answer. And you get 7.746. Approximately. Now, that standard deviation, think about that. You're saying that He is 7 standard deviations away from the rest of the group. He is far away from the mean that we expect. Steve is far away from the rest of the group and the mean. Therefore, we think his die was loaded. Okay, so far away from the group by finding the z-score. So you find the z-score, and that tells you how far away from the mean you are, right? Far away from the mean. Technically, it's from the rest of them, but it's technically from the mean, but that also means the rest of the group. Let me reverse that. Sorry about that. From the mean, because what you're doing is with the z-score, you're not finding the rest of the group. You're taking this subtraction from the mean. So let me use that. So since you're far away from the mean, we think the die is loaded. That's the classical method. So 2 ideas here. The p-value method means it's a very, very low chance of getting what he's got. So I think that it's loaded. The classical method says find the z-score, and then if that's a big, big number or a really, really small number, like negative 7.7, then that's far away from the mean, and we think it's loaded. Remember that in chapter 2, or chapter 3, we said that 2 standard deviations was unusual, quote unquote. This is 7 standard deviations. This is very unusual, right? I just added that as a little note. His z-score is well past the threshold for highly unusual, which was 2 standard deviations up until this point. But once we hit chapter 9, we stopped using the 2 standard deviations, quote unquote, and started using our alpha, right? Our, what's our threshold? It's 90%, or, we only want 0.05 in the tails, that kind of thing. So that's where our threshold's going to come now. All right, so that's the basic idea. Keep this example in mind all through hypothesis testing from here on out, because we're going to keep hearkening back to it. Things are kind of rigged, right? Something is rigged one of 2 ways. Either because the probability is very, very low, and no, you will not have to use the binomial probability to find it, but you'll use the normal probability, or because the z-score is far above what you expect, right? Or below. It's actually just far away. So you can be far above to the positive direction, or far below to the negative direction. Like -7 would be bad. And just on a side note, before I leave this example behind, because we're going to recall back to it a couple times, I want you to know that there was actually somebody else who cheated in here, but you didn't know it. So when I did this in class, I gave out a rigged die to somebody who had all 5s, but I also gave out a rigged die to somebody who didn't have any 5s on their die, and they didn't realize it. So just on a side note, you can't prove that it's rigged if you don't have evidence for it, right? So we want the evidence for proving that the die was rigged. And it's not hard to see for Steve, but it is hard to see for this other student who's right up here. There, I just added that piece as a little note down here. So we had another student had a rigged die as well, maybe as well. One of the 0-5s was rigged, was a rigged die. But we didn't realize it looking at the evidence because, or looking at the table here, because we didn't have strong evidence for it that we had for Steve. And his die. All right, so I'll refer back to that as well in a later example. So keep that part in mind. And we're done with just this little bit of setup, and I'll meet you back here to talk more about hypotheses.